Hello and welcome back to the shop. Just a little update as to progress with the planing machine. You can see the overhead frame there above the planer. You can see I've fitted the motor now. Let's go over and have a look. You can see that now. There you are, you can see the pulley. I've made that pulley. It's not a crown pulley, it's just a straight one. I have made a crown pulley, which is going to be the driven one, which will be on the shaft. And the shaft will be where we said on the last video, it's going to be up here. The driven pulley will be here. The drive pulley for the planer will be here, or one of the drive pulleys, and the other drive pulley will be here. Now we're going to be fitting on that shaft, we're going to be fitting SKF or Timken. Timken are owned by SKF. Self-lining spherical roller bearings. And what's really important with installing the self-lining spherical roller bearings in the pillow block housings is to determine which one you're going to use for the location. Alright, it's really important. You only ever pick one bearing that's going to be located. The others must always float. And that way you allow for expansion and contraction. If you try and locate more than one, you'll have big problems. If you don't locate any of them, you're going to have big problems. One has to be located. Okay, and in this instance now, what I'm going to do is locate the bearing here on this one. When I talk about locate, I mean fix its position on the shaft so it can't move. So it'll be fixed in its housing. The bearing itself will be allowed to float inside the housing on this side. So any expansion and contraction will be from that point there and that point there. Will be negligible that side. You'll get a slight amount there, but we always make sure you never ever locate two. You only locate one. So you need to look at your application in detail to determine where you're going to locate your bearing or how you're going to locate it. All right, let's go over and have a look on the bench and just see what we're doing now. All right. Look at this fella here. This is the pulley I made. This came from Reeves in, I think they moved from Birmingham. They used to be in Birmingham, Model Engineer Suppliers. This was actually a flywheel off a model internal combustion engine. I bought the raw casting from Reeves. I think it was called Marston. But it lent itself perfectly, in my opinion, to make a pulley. You see a lot of pulleys on eBay and they're pretty expensive and they're not really what I wanted. So I thought I'd make my own. So you can see, there we go. It's just under 8-inch diameter. I'm not too worried about that. But you can see from the profile it is crowned. This is going to be flat belt drive. The planer itself, the two belts, will be flat belt drive. What you need to understand about flat belt drives is that the belt, and this applies to conveyor belts too, always run to the tight side. So the tightest point is where the belt always runs. So if you see a belt that's tracking over to one side, it's tight on that side. You need to do something about it. So crowning the pulleys hopefully makes the belt track in the middle. So there we are. I've just fitted that pulley to the shaft. We'll have a look at some of the bearings now. Got the two bearings. See, the Timken, these are very good quality bearings. Trying to do this with one hand now. All right, let's have a look. This is the split pillow block housing. We take the cap off and we fit the bearings inside that. All right. These are the bearings. Self-aligning spherical roller bearings. Reason why I chose these was because what I wanted to be able to do was to align the shaft. So I needed a certain amount of misalignment capability, because we can't guarantee all the pads or whatever are perfectly square, parallel, whatever. So I needed a self-aligning capability, and this particular bearing gives us this option. So I do like self-aligning spherical roller bearings. They can accommodate for heavy radial loads. In other words, a load at 90 degrees to the shaft, center line, and they can accommodate for reasonable axial loads. But if you're thinking of using these, always check with your supplier. Tell them exactly what your application is, and they'll recommend which one you should have. I mean, I could have used self-lining ball bearings, but I prefer these. They're way more capability, and for the extra cost, I thought it's worth doing. Probably never do it again in my lifetime. So anyway, there we are. This is the bearing. We can have a look at that in a minute. In fact, we can have a look at it in 2 seconds. Okay, there you are. That's the bearing still in the wrapper. I won't take it out because I want to make sure I don't get any dirt and shit in there. Here you can see, I don't know if you can see it just moving its pivots. It pivots about the outer race. I think they can allow for, is it something like 2 or 3 degrees misalignment? But what people need to understand about these is, once you set the position, even if there's misalignment with the shaft, it's not designed to wobble like this and go backwards and forwards. It's designed to stay in whatever position you set it at. Well, there you are. That's the SKF self-aligning spherical roller bearing. It's extremely high radial load capability. So that's that. We've got, what are these fellas here? These are the taper adapter sleeves. These will be the taper adapter sleeves that the bearing itself fits on. The bore in that is tapered. The outside diameter of this is tapered, and we've got a lock nut and a lock washer. We'll be fitting them on as well. And what are these here? I think these are the seals. Let's have a look. Oh no, these are the locating rings. I was talking about location of the bearing before. These are the locating rings that will locate that one bearing. They're the seals in there. Alright, so these are all the parts that we've got, and we're going to start installing this stuff now. So let's get on with it. Okay, you can see here I've actually taken the cap off. That cap will only fit one way, and that's really important. You can see the Grover pegs here, or Bissell pins. They align the cap. And this cap is unique to that housing, or that base. You never mix them up with something else. They've been machined as a pair. Always keep them together. And keep them clean as well. You can see what I've done here. I've put up, there's 2 provisions for greasing here. I've blanked that one off, and I've put my grease nipple in that one. You'll also see of interest too, at the side you've got a little plug. This plug is for oil level. So you can, in some instances, fill these with oil. I've never seen them filled with oil. I've always seen them filled with grease, never oil, but it gives you that provision. And I'm sure, you know, if you explain your application to SKF or whoever, they'll tell you what kind of lubricant you need. But anyway, this bearing, this self-aligning spherical roller bearing, will fit in there, and you can probably see you've got a gap either side. That's where the locating rings go. They'll hold that and locate that bearing, and the other bearing we won't have any, so it can actually float. The bore in the cap is a clearance, and it's a very light clearance. When we've finished tightening the taper adapter sleeve up, the inner race of the bearing will be an interference. And it's important to remember about bearings, rolling bearings, whichever item is the rotating part, that is the interference fit. Whichever one is the stationary part, that's the clearance. The housing is stationary, that's the clearance. The shaft is rotating, that's the interference. Yeah. Okay, right. We're going to unwrap these, and I'm going to put this on here, and what I'm going to do is I'm going to check to see which direction this is going to rotate, because it has an impact on which side we put the lock nut. Okay, so I'll just do that. Okay, you can see I've fitted the taper adapter sleeve here. That's the way around it's going to go. So when we'll put the tab washer on, like so. We'll put the lock nut on and we'll drive the inner race of the bearing up the taper. It will expand the inner race of the bearing, reduce the clearance between the rolling elements and the raceways, which is exactly what we want, and it's predetermined clearances that we need set to, and that will give us that interference. It'll lock everything in place. Now if this is rotating anti-clockwise, I need that so if anything happens that would try and tighten up, it wouldn't come undone. So that's the right way around. There's no oil or anything on this shaft. I don't want anything to hinder us tightening that up when we come to do the drive up on the bearing. So we do it dry. There'll be plenty of grease on that thing after it's installed in there. But anyway, we're going to fit that onto there, and we're going to have to center it. We're going to have to gauge exactly where that's got to be. So when we do our final drive up, the bearing sits in the correct relationship to that edge there and this edge here. I want it central. Okay. Okay, you can see the bearing here. You can see how the outer race can move at an angle. And be careful with these. You don't want to jam them and force them or anything like that. But that's your self-aligning property there. Once you set it, whatever position it is, it must stay where it is. Okay, and we're going to put this onto there. You can see that diameter is bigger there, smaller there. So it goes on that way. And it goes up the taper. Okay, be very careful with this. Alright, and now we'll put the tab washer on. Never forget the tab washer. Where's the little thing there? I'm going to put the lock nut on. And I'm going to start measuring now. And I'm going to get me book and I'll check what clearance we're going to feel gauge that between the rolling elements and the raceway, because you'll be able to lift that up and down as a slight movement. Right, some of them, the small ones, maybe like this, it's not really that relevant to us because it's difficult to measure. But you're working on a big bearing, that's perhaps 12-inch, 18-inch bore. It's critical. It really is critical. I think we'll probably just be working on resistance. We just feel the resistance and we adjust that nut to suit. Alright, I'm just going to have a look at that then. Okay, what we're doing now is we're tightening this. Yeah, well, that's nice and tight that is. Now we feel this and we've still got you can feel a little bit of resistance. And I'm happy with that. Because see on bigger bearings, you'll actually get your feeler gauge and you'll put your feeler gauge, because the raceway will drop down, you'll put your feeler gauge in to measure the gap between the rolling elements and the outer raceway. And that will determine as to where the setting needs to be. You check your tables. SKF will give you the information that you need so you can work out, and it'll be determined by load, speed and all kinds of other things. But they'll recommend to you what's required. Anyway, that's where I want it now. I'm happy with that resistance. I'd never get a feeler gauge in there. For the size bearing, the actual radial clearance, diametral clearance between the rolling element and the outer raceway would be negligible. But anyway, what I'm interested in is, that's slightly off. It's not far off there. About 1 3/8. That's moved, isn't it? It's not far off 1 3/8. That's okay, so it's pretty central anyway, that's all we wanted. Alright, now that will fit. And I'm going to do this so that also the drain would be on the outside. So I'm going to fit that like that. So that now would go under there. And you can see that's going to be in the centre. We've still got to fit the seals. And we've got to pre-pack this with grease as well. And we've also a really important job we've got to do that I've forgotten about. is we've got to knock one of the tabs down. We must make sure that one of the tabs is knocked down so that nut can't come undone. Okay, I'm going to do that now. Okay, you can see I've knocked that one down there. I've just used my little parallel punch, my hammer, just knocked it down. Don't go mad. You don't want screwdriver marks or chisel marks in that. The wrong tool completely for the job. Get the right tool. Alright, so there we are. That bearing now is fitted to the shaft. Exactly where I want it. Alright, what we're going to do now is we're going to get the seals. We're going to put the seals into the bottom half. We're going to fit them into the top half as well, and they split seals. We're going to get the bottom half. We're going to offer it up. What we need to do then is we need to fit the locating rings. There's 2 of them here, and they're designed so that you can pass them over the shaft and then you can turn them round. You need to get most of the ring probably in the bottom. I prefer having them in the bottom, so you've got some in the top. But for me it's the bottom because that's where the base is. That's where most material is there. Okay, so what we're gonna do is put the seals in here, offer that up, put the locating rings in, and then we can look at putting the cap on, but we're going to grease pack it first. And I'll just give you some indication as to how much you need put in as well. So just let me do that. Okay, you can see there I've packed the bearing with grease. I've just used some general purpose grease with extreme pressure, EP, extreme pressure additives. K42 EP, this is Morris lubricant stuff. That's good grease. We used to use Morris stuff all the time. A lot of good manufacturers of lubricants out there. Check with them which one you're going to use. Alright, it's full of grease. I've pre-packed the bottom half, and I've not put anything in the top half here, but I've put some grease on the seals to allow them to bed in. I don't want them, when the shaft starts turning, I don't want anything dry. Okay, so what we've got here then is our bottom half and the top half. The top half, as I said, has got nothing in, and what I'm after doing is packing this between 1/2 and 2/3 full. So when you think I've got that packed, that's pretty much packed, and I've put nothing in there. We're going to do about half full, and that allows somewhere for the grease to expand into. If you pack that completely full, you'd have major problems with overheating and the bearings failing. Okay, so what we're going to do then is I'm going to put that underneath there. Let's see if I can do that. Don't forget we said the drain is going to be on the outside. So that goes up there, like so. Just I'm going to put you down for a minute. Okay, there we are. We've got the bottom half on. I've put the 2 locating rings in, and that stops any end float. Alright, so that bearing's locked where we want it in relation to the housing. Right, I'm going to put the cap on now, and I'm going to put the bolts in. Okay, I've just seen one anomaly. I don't know if you can see, but there's a gap between the seals here. I think they've given me the wrong seals. These are probably for a 3/4 inch shaft. It should be for a 1 inch shaft. So what I'll have to do next week is sort that out with the supplier, get the new ones. I'm going to leave it as it is for the moment, because my bearing's safe inside of there, and I want to fit the other one. And what I want to do is to set the distance between that and the other bearing. So we'll check the centres. I'm pretty sure they should be 11.5, but we'll check the centres up on our frame, and we'll set the position of the bearings to suit on the shaft. So I'm going to start working on this end, and I might turn it round. So I've got the bearing here. When I get the proper seals, I can easily just take the cap off and just swap them over, but I'll leave it as it is for time being. Alright, let me just turn it round. Okay, I've turned the shaft around, as you can see, and I've turned the bearing upside down here. Alright, the hole centres between the 2 bearings should be 11.5 inches. So what we're going to do is we're going to mount this bearing on here now, and we're going to set the position so that the housing is dead central with the bearing and centre with there, and that's 11.5 inches. All right, we'll get the other bearing out and we'll have a look then.